Okay, guys, welcome back. Right, we're on session 3 now. Some fantastic work so far. Continuing with binomial expansion. So this is binomial expansion part 2. We're going to use Pascal's triangle again, but we're going to look at some sort of slightly different problems in this session and see where we go from there. Okay, right, here we go. Okay, we're going to start with a little bit of a recap. So we start with a bit of a recap. So if we've got a question, find the x cubed coefficient of the expansion 3 plus 2x power of 5. Okay, so we looked at this in session part 2. You might want to pause the video at this point and have a go yourself and see if you can remember how to do this before watching the solution. Okay, so pause it. But here we go with the solution. Now, what you need to do is, what I'm going to do is I'm actually going to write down Pascal's triangle down the side. Now you can create this because it's 1, 1, 1, and then remember the middle number is the 2 above added, so 1, 3. And you can create this quite quickly. We probably might go to 1 actually. Okay, so that's the Pascal's triangle. Remember the top row is x plus a plus b to the 0. This one's a plus b to the 1. And so on. So this is going to be 3, 4. So we're going to use this row here. Okay, we're going to use that row there to help us. Right, the x cubed coefficient. I'm only interested in the x cubed. Now the way I'm going to get x cubed is if I have 2x to the power of 3. Okay, so the term I'm interested in, I'm not going to expand the whole thing. I'm just going to look at 2x. I need that part of the term to be to the power of 3. Now that means if that's to the power of 3, the a bit, or the 3, that must be the power of 2, because remember what we said last time, these two powers must add up to 5, which is the total power there. Okay, now I need to get the coefficient in there, which comes from Pascal's triangle. So this comes from Pascal's triangle over on the right hand side. Now this was, so remember a is equal to 3, b is equal to 2x. So that was the 1 over here. That over there, that's a to the power of 5, a to the power of 4, a to the power of 3, a to the power of 2. The a to the power of 2 term will have a 10 in front. Okay? So I'm going to go straight in, put a 10 there, and that's where that term comes from. So if we carry on, we can just simplify this now. It's going to be 10 times 3 squared, which is 9, times 2 cubed, which is 8, x cubed. That's going to be 720 x cubed. So the coefficient, remember it's just the number in front, is equal to 720. Coefficient of x cubed is 720. If you were to expand that, you'd end up with the 720 x cubed term. It's quite useful. Okay, let's look at a slightly different problem. So question 2. Now, the coefficient of x to the power of 4 of the x to the power of 4 term in the expansion a plus 2x to the 5 is 400. Find a. Okay, so the coefficient, this time it tells us what the coefficient is, and we're working backwards. So again, you might want to pause the video at this point and have a go at this question. Okay. Right, so looking at the x to the power of 4 term. Now in order to get the x to the power of 4 term, it's going to have to be the 2x to the 4. Now that means the a term, so a has got to be to the power of 1. because the powers must always add up to the overall power. I then need to have a look at what needs to go in here. The Pascal's, this is the Pascal's triangle bit. And I go back over to my Pascal's triangle. Luckily it's the same row because it's to the power of 5 and it's the a to the 1. Sorry, it's the a to the power of 1, yeah. So this was a to the 2, a to the 1 because we go down each time, a to the 1. This time I'm going to be looking for 5 goes there. 5 goes in there. And it says all of that, that's going to be the x to the power of 4, but the coefficient of that is 400. So it's going to be 400 x to the power of 4. That term has got a 400 in front. Now from this point onwards, I can sort of simplify this a little bit. I've got 5a, 2 to the power of 4 is 16. X to the power of 4 equals 400 x to the 4. I can just compare coefficients now. So I can compare coefficients. So the x to the 4s can just disappear. So I end up with that's going to be 80a equals 400, which is really, really nice. So my answer A is equal to 5. And that's what the question wanted. It wanted 5. So if I expanded 5 plus 2x to the 5, I would end up with one of the terms being 400x to the 4. Okay? Right, I want you to do a couple of questions similar to that. So they're on the video and they're not from the work, they're not from the textbook yet. So what I'm going to do is I'm just going to pause the video now. See if you can answer these, please. Give yourself definitely pause the video. I'll give you a couple of minutes on this at least to work through each of these 3 questions. Okay, so when you're ready, guys, off you go. Okay, that's about time. Here's the solutions to those. So you've got question 19. You should have got A was -3. Again, pause the video if you need to see how that's done. You only really need to focus in on the one term. The person who's done the solutions here has done loads of them, but you don't only need to focus on the one. Second one is 2 or -2. Okay, and the third one we should end up with 7 or -7 for A. Okay, so just take some time. There's some really important questions to have a look at, and that they come up a lot in this course. These sort of questions. Okay. Right, we're going to do just one more thing. So we're going to look at an independent term. So independent terms. It's not much different to what we've done before. So you might be asked to find something like this. So find the independent term in the expansion 2x plus 1 over x power 4. Okay. So the independent term. Now, independent term means no x's. Okay. So we want the term that has no x's in, or the constant term. So it's going to be like +4 or +5 or something like that. It's just a number is what we're looking for when it says find the independent. Okay, now you might think, well, we've got x's in both here. We're never going to get an independent term. But you'll note that if I do 2x times 1 over x, can you see the x's all there? They will cancel out. So I'll end up with 2. That would be a independent term, 2. Likewise, if I had 2x, say, cubed times 1 over x cubed, the x's will cancel out because that will end up with 8 there. The x cubes this time will cancel on the top and the bottom. And we're going to use this fact to work out the independent term for this expansion. Okay. Now, there is a long way of doing it. You just expand the whole thing. Or there is a quick way where you can spot what is going to make the independent term. Okay. So if we just go back, so we know a in this case is 2x, b is 1 over x, and we're looking for the 4th power. So just go back to my Pascal's triangle, right up here. Pascal's triangle, it's the one above, the row above I'm interested, 1, 4, 6, 4, 1. Okay, 1, 4. Roll down again. So the Pascal's triangle row is 1, 4, 6, 4, 1. That's the row Pascal interest. Now you might think, okay, it's to the power of 4. Which term is going to make me have an independent term? And it's going to be when the 2x power and the 1 over x power is the same. A bit like when we put in the note here. You see there was just an x there. 1x over x made 2, and then x cubed over x cubed gave us, that just made it disappear. And because it's to the power of 4 and the powers need to add up, the term I'm interested in is going to be the one that has 2x squared and 1 over x squared. Okay, I need to remember, always put the Pascal's triangle factor in the front there. But that's the term, because they're both going to be squareds. That means that's the term where the number's going to be, the x's are going to disappear. Now, if it's a to the power of 2, this is, remember, a to the 4 term there, a to the 3, a to the 2 is, that's 6. So it's definitely going to be 6 that goes in front there. So if I carry on, I'm going to get 6 times 4 times x squared times 1 over x squared. And now you can hopefully see the x squareds are going to cancel. And I'm just left with a constant or an independent term of 24. Okay, and that is and that's how you work out the independent term. You could do the long way of expanding the whole thing, and you will end up with a term. One of them is 24, but you can find it much quicker if you can spot the tricks of what's going to cancel x's out. Okay. Right, I'm just going to give you a couple of questions to do from the textbook this time. So it's page, yeah. It's page 17, exercise 1F, and you've started this already, but I want you to have a go at questions 12, questions 13, please, okay? And that concludes session number 3. We've got 2 more sessions to go on chapter 1. You're doing really, really well, so keep it up, guys, and I'll speak to you next time. Well done.